A warm welcome to all the viewers. In this session, which is a session in the series of bibliometric analysis, session number 7, we are going to specifically talk about three important analyses which are given to us by BiblioShiny application on the data which we have uploaded in it for the bibliometric analysis. These three are reference spectroscopy, also known as RPYS, reference publication year spectroscopy. Then is the degree plot and tree map. Often it is seen that scholars struggle on the interpretation of these three. So I am here to clear you out in a very simple manner how you can easily interpret these three parameters. So let us start. What is reference spectroscopy? It is a bibliometric technique analyzing citation years to map the history of research in a particular field. Easy? To identify the peaks of influence, right? So, it is a technique in which we analyze the citation years. Say for an instance, what was the citation of a particular document or an article in a particular year. So as we come to know the popularity, the importance, the relevance or the significance of that article in that particular domain. So here am I in my Web of Science advanced search and I am searching for AI and academic writing in topic. So topic means it will search in for these three keywords in the title, abstract, keywords and keywords plus. So when I search, you see I got 414 results. I can filter them out as per what I need. So in this case, if I just need the articles, I don't need the proceeding papers, I don't need review articles, early access, editorial material. So I just click on article and click on refine. So once I click on refine, now you see instead of 414, which was the earlier figure, now I got 293 documents. These are the articles. So I need to export them. I click over here and go to export and export them in a plain text file format. So plain text file format, and here I select all records 1 to 293 and then record content, full record and cited references, export. This is the way I export the data from Web of Science. Now it will be downloaded on my system and later I can import the same data which is downloaded right here into BiblioShiny for the analysis. So you see it's being downloaded, this file saved records. Now I go to RStudio. This is RStudio, and now I open the bibliometrics library, bibliometrics. So you type in this command, press enter, and then after that you type BiblioShiny. Once that command gets executed, you have to type BiblioShiny and round brackets closed and press enter. Now it will take you to the BiblioShiny application, which is a web-based interface but doesn't require internet for running. It can run on your local system. So we'll import this data, saved records, into BiblioShiny and see how these three things are done. RYPS, degree plot and tree maps. So now I import the data, import or load data, import raw file, right, which we have taken from Web of Science. So I select Web of Science. You have so many options over here, the database from where you have taken the file. In our case it's Web of Science, and then surname and initials, that is okay. Browse, I go to this saved records you see here and bring it in, start. So there are 293 documents as we saw. So you see everything is present over here in good condition except the keywords plus, so that is okay for now. Keywords plus are basically automatically generated keywords by Web of Science. They are not available in Scopus database. They are automatically generated through the references of the articles which you have included in your analysis. How? Through the references which are mentioned in the articles which you have taken for the analysis. Each article must be having several references, and those references would be having a title in itself. So out of those titles, Web of Science has automatically picked up the relevant keywords to show you as keywords plus. So when you take data from Scopus, you don't actually get keywords plus, you just get keywords. So that is okay for now. I click on close. So let us now see the metrics which are used to assess the reference spectroscopy. These metrics are given to us by BiblioShiny. Basically, there are two metrics to assess it. One is differential median, which is the difference between document citations and median citations for that field's publication in a particular year. If I go to differential mediation 5, that means the same thing done over a span of 5 years. If we talk about 5 years, that is a more stable measure in comparison to 1 year, right? So why do we consider median, not mean? This is because of the skewed nature of the articles. The cited articles, here we see that the less cited articles are more in number and the more cited articles are less in number. So that leads to the formation of a skewed distribution, and we all know in case of skewed distribution, median is a better way of assessing the distribution rather than mean. So the central tendency of the distribution can be better assessed through median in this case. Then when we say median, then we have to make one out of these two choices which are mentioned in BiblioShiny for reference spectroscopy. One is centered, which uses a center 5-year median starting from the present year, going back to last 2 years, and then going forward towards the coming 2 years. It provides a smoother curve by considering the context of a specific year and its immediate future and past. The backward integration. Now this is 5-year median from the current year till the last 4 years. So last 4 years and the current year makes 5 years. It considers only the past data up to the current year for median calculation. This is robust for analyzing real-time trends as it does not depend on future citations. So this is a better method, and by default the backward method is activated in BiblioShiny. Now when we get the plot of reference spectroscopy, there are black lines and red lines. Underneath the black lines we can see the red lines in that plot. What do the black lines tell us? They portray the number of cited references per annum, reflecting the cumulative citations of documents in the collection annually. Years which possess a high number of citations suggest the presence of influential publications that could be considered foundational or landmark studies in the field. So if you have high number of citations, it suggests the presence of influential publications in that particular year. Now red lines portray the deviation from the 5-year median score. So the 5-year median score which we have taken, red lines portray the deviation from that. In case you have a small data and you do not see any deviation between black and red lines, that means there have been no influential publications as such in your data. So it's all going normal. Comparing the current year with the previous 4 years, that is current year -1, -2, -3 and -4. So that makes up the 5 years, and then we take out the median of that. It highlights the prominent peaks in citations, lending a smooth comparison over the time to identify the highly cited years of certain documents. So now let us go to BiblioShiny and see how does it look like. So here we are in our BiblioShiny. Under documents you can see references spectroscopy. I select references spectroscopy and then I click on play button. So I'll get a plot, and let us see whether there is any deviation or not. So in this plot you can see a red line and a black line as we discussed. So when we see 2004, you see here total citations 99 year 2004, and there have been no major deviations because the red line also tells us the same, total citations 99 year 2004. So if you have a close look on this, you'll see that red is just going along with the black. So there is no major deviation in our data. We can see the same thing through the table. Now in table also you see starting from year 1926 till 1935. If I display all the rows, you see starting from 1926 till 2023, whatever publications we have taken in as a database in BiblioShiny. So that tells us the differential median for 5 years, and this is based on backward bibliometrics method, backward integration method, wherein we are just considering the past 4 years and the current year. We are not looking into the future. So that is how you look into it, and then you can go to table of cited references. Herein you can see in 2025 this article by Kim J in Educational Informational Technology received 17 local citations. By local citations I mean it compares this article with all the other articles which are present in our database and which has been input in BiblioShiny. It cannot go out of the database to look in for. That's why it is known as local citations. Then we go to table influential references. Herein we can see these are some of the hot papers. Hot papers mean quite influential papers. And 2001 local citations is 2. 2003 by Park C, it has 3 local citations. Then 2023 Salam 2023, it has got 15 local citations. And here is the link. If you click on that link and your internet is on, you'll directly go to that paper, and if it is a open access you can access the entire paper. Otherwise you can go through the abstract to find more about what is mentioned in this paper, right? So that is how you do it. If you want it as per the sequence of citations, so we'll just click over here, you see. So I just clicked it and we got the top cited by Salam 2023, that has got 15 local citations. Top 10 peaks, so top 10 peaks you see, again I click over here in terms of local citations, and 1989 Davis 1989, this MIS Management Information System Quarterly Journal, so that is an article which has received local citations of 13. So that is how you do it. And there is a feature known as Biblio AI. So in case you have the Google Gemini account, and that's a kind of a paid service, you have that, you can go to Ask Biblio AI and it will automatically interpret the plot which you have got, and you'll get the results for that. That is how you do it. Now let us go to tree map. If we see tree map is primarily designed for visualizing hierarchical data structures and showing the relative proportions of different categories within that hierarchy. The size of each rectangle directly corresponds to its occurrence or value, and the color of each rectangle helps to distinguish between different categories. So let us go to BiblioShiny and see how does it look like. I just click on tree map and click on play button. So this is the tree map. This is based upon, you see, all keywords. We have the options keywords plus, authors keywords, titles, abstract, subject categories, right? So based on all keywords we have got this. If I change it to titles, so I say unigram, that is a single word, then I play it, then you see it will change. So based on a single word present in the article title, present in the title of the article which we have uploaded, the articles which we have uploaded, it will look in for the single word and find out which is the most occurring single word in the title of those articles, right? So you see here writing occurs 181 times, that is 13% of all the different words which are there. Academic occurs 161 times, that is 12%. AI occurs 103 times, that is 8% of all. So if I go to keywords plus, number of words I can also adjust 50, 55, I can go to 45. So if I just want to see 25 keywords plus, so as this is Web of Science data, I can go in for keywords plus. I don't get it in Scopus data. So here I got ChatGPT 21 times. Okay, so 13% of the total. Now in a table form, you can get it in a table form, you can export it, or you can add it to the report by clicking on plus button, add results to the report, or you can download it, export plot as PNG. So that is all about tree map. Now let us go to the third thing, which is a degree plot. Now what is a degree plot? It shows how the connections, that is degrees, are distributed among the nodes. What is nodes? Keywords, authors or sources in a co-occurrence network. So co-occurrence means how often do they occur together, right? Keywords, authors and sources, how often do they occur together? It plots the node levels against the cumulative degree to help identify key themes, influential authors or major publishing sources as present in the uploaded database on BiblioShiny. So whatever we have uploaded on BiblioShiny, it is just going to consider that and give us the assessment based on that. Now in that degree plot, first of all we see a steep initial slope which indicates highly linked fewer nodes and it is the most influential. Then we have a gradual slope where we see nodes are moderately linked to each other. This has a significant contribution but not dominant as the steep one. Then third one is the flattened right side on the degree plot, which infers a low linkage between many nodes. It shows a low linkage between many nodes, which is less influential. So let us go and see a co-occurrence network to find out how does degree plot look like in our case. Conceptual structure and co-occurrence network. You see here under conceptual structure you have co-occurrence network. I click on that and you see here that's a beautiful map and it shows different clusters as well. This red one, green one and blue one. Now it is based upon what? Let us see. All keywords, author keywords, titles, abstract. So I can select anyone. Say I select keywords plus. Okay, I select keywords plus. Text editing can be done over here. Load a list of terms to remove. So you can prepare a list in Notepad and upload it in case you want to remove those words. In case you feel that there are two words which mean the same and you want to put up a list so that it just displays one out of them, then in that case again you prepare a Notepad file and upload it over here so that it removes it, right? That is how you do it. And then keywords plus. So based on keywords plus, I just click the play button and I see. So I see this plot based on keywords plus and you see the linkages, the network is over here based on keywords plus. So you see artificial intelligence. So it's occurring the maximum number of times and this word is linked to the challenges. So you see wherever challenges is mentioned, artificial intelligence is also mentioned. Wherever information technology, user acceptance is mentioned, artificial intelligence is also mentioned. Wherever feedback is mentioned, artificial intelligence is also mentioned. So it is connected to 4 different nodes and that is why we have artificial intelligence as a big round circle. Similarly, if you see English over here, so English is connected to genre and then meta source, disciplinary features. So that is how English becomes a bigger circle, right? So that is the interpretation of co-occurrence network. If I want to see based on say titles, so in the titles, which are the words which are occurring most frequently in all the articles which have been uploaded by me, and I want to see the unigrams, single words, I click on play button and it will show me. Now you see in most of the articles I see that academic word is occurring and you see it's a big round red circle. So that shows the intensity the density of academic, the influence of academic word, and it is connected to these small red circles which are the other nodes. So wherever you have perceptions, you have academic. Wherever you have university mentioned, you have academic in the title. Similarly, writing is well connected to academics. So you see there is a big strong connection. That's why it's a thick red line between writing and academic, which connects writing and academic. We go to density plot, and here you see academic and writing being in the center of the heat map. So they are the most influencing words, and they influence all other words, and all other words do mention them. So wherever we have the other words, other things, we do have academic and writing also mentioned in the titles of those articles. Then we can see this in a tabular form. You see here betweenness and closeness, and then you have the cluster number, right? So if I say show all, so in that case I'll see cluster 1, cluster 2, cluster 3. So whichever clusters are being formed, and cluster 4. So there are 4 clusters being formed. I can see them through here, and I can even take out it as a Excel. Then I go to degree plot. So degree plot, this is the degree plot. This is the first part which we saw, the steepest part. Herein we see writing and academic closely related to each other and on the steep, right? As we saw in the PPT also, steep initial slope, highly linked, fewer nodes, that is the most influential. So in our case, writing and academic, steep slope and highly linked nodes, right? And they are the most influential. Now the second one is gradual slope. Nodes are moderately linked. They have a significant contribution but not dominant. So this is the part, this one from here to here. You see several nodes are coming together. They are close to each other. So they have a significant contribution but not as dominant as writing and academic. Then we have the third part. You see here, this is the third part of the degree plot, which is a flattened right side, low linkage between many nodes. So you see it is kind of a flat as compared to the steep and the middle one. So where we see many different nodes are connected to each other, but they do not have a higher influence on the theme area. So that is how you see they are less influential. So that is all about the interpretation of reference spectroscopy, tree maps and degree plot in BiblioShiny. I hope the session was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time in a new session with some more analysis on BiblioShiny. The series is not over yet.